section of chapter 4, using matrices to solve systems of equations. So this will be the last section we do in chapter 4, which is another way of solving systems of equations using matrices. We already talked about Cramer's rule, which was one way. Today we're talking about the second way, which is using inverses. So a matrix equation, this is different than the equations we set up using two matrices early in the chapter, way back in section 1. A matrix equation is a system of equations that you're taking the coefficients from and putting those into a matrix itself. So what we've done here, we've taken the coefficients from the x's and the y's. So I had A and C, and that became my first column. And then B and D, and that became my second column. Very similar to what we did with Cramer's rule. Just not a determinant, it's a matrix. Then I have a separate matrix that's x's and y's. It's just an x and a y. That's it. It's always going to be that. And then the things that are by themselves on the other side of the equal sign go in a matrix by themselves on the other side of the equal sign. And that's what you set up. This is a matrix equation. So all we want to do for this first example is set up matrix equations for these two systems. We're not going to solve them yet. We're going to get there in a minute. So for this first one, we're going to take the coefficients, and that becomes a 2 by 2 matrix. So we have the x's are in the first column, and then we have the y's are in the second column. Then you have the x and the y by themselves, and then you have the other ones over here on the other side of the equal sign. So it still kind of looks like you have your systems, but the only thing here is we have the x and y separate from where it is here. So let's go ahead and do the next one. We're going to have that constant matrix, so we have the 2, 4, 3, negative 1. So we have the x coefficients and the y coefficients. Then I have an x and a y is equal to 7 and 6. That's all there is to it, to writing matrix equations. So that's how you write one. Now we're going to talk about how do you actually solve these matrix equations. What we do is this. We're actually going to do another one. We're going to write more equations. So here they give us this table. We have wool, silk, and cotton. They've just labeled these different types of fabrics. They have a combination for fabric R. We don't know what that is, just fabric R has 10% wool, 20% silk, and 70% cotton. And then as you increase the silk and the wool and decrease the cotton, the price goes up. What they want us to do is to create a matrix equation, or excuse me, a system of equations first, and then a matrix equation. So I'm going to go ahead and set that up. So to set this up in a system of equations, we're going to have just the percentages as decimals. So 10% is 0.1 W plus 0.2 S plus 0.7 C is equal to $7. So then we have 20% wool plus 30% silk plus 50% cotton, that's $8. And then when we have 20% wool plus 50% silk plus 30% cotton, it costs $10. And this is our system of equations. So it's a three variable system. Now all we do is create those same, we pull out those same numbers. So we have 0.1, 0.2, and 0.2 for the W's. We have 0.2, 0.3, and 0.5 for the S's. And then we have 0.7, 0.5, and 0.3 for the C's. We have the variables, so we have W, S, C. That's going to be equal to the dollar amount, 7, 8, and 10. looking at these, we're going to be using inverses. So for instance, when we want to solve ax equals b, we divide both sides by the constant a, and we end up with x is equal to, actually what becomes the multiplicative inverse of a times b. We want to do the same thing with matrices, but we can't divide by a matrix, we multiply by its inverse to get rid of it. So here we have a times x is equal to b, where x are the x and the y's, and a is that constant function, or the constant matrix. I'm going to multiply by the inverse of a. So we define the inverse of this, and we multiply both sides by that inverse. Well, this cancels because that's the inverse times itself is just the identity that we talked about yesterday. When we multiply these two matrices, we're going to get our solution. And so that's the steps we're going to go through in practice right now. So taking a look at this first one, let's start by writing a matrix equation. So we start with 6, 3, 2, negative 8 times x and y is equal to 11 and 1. Now, I almost want to kind of move off to the side here for a second and find the inverse of this particular thing. So finding the inverse of this, remember, we multiply by the 1 over the determinant. So negative 48 minus 6. And then we switch the negative 8 and the 6, and we make these two negatives. So we have 1 over negative 54 times negative 8, negative 2, negative 3, and 6. Now notice, this is not going to divide out evenly. So we are not going to actually multiply through by this. I'm just going to multiply both sides by it. So when I multiply both sides by it, we end up with 1 over negative 54 times that inverse matrix, which is negative 8, negative 2, negative 3, and 6. Then I'm going to keep the regular matrix, 6, 2, 3, and negative 8, times x and y, equals, and now I have to put this inverse, this whole thing together creates the inverse. So I have to put that whole thing on the other side. And then multiply that by our 11 and 1. So notice when I go to multiply these, I have a 2 by 2 and a 2 by 1, so it's going to match and it's going to be able to be multiplied. Now if I've done this correctly, all of this should get me the identity. So I'm not going to make you multiply that out and check it every time. If you just want to make the assumption you did it right, we got the identity. So if you do the inverse times itself correctly, you should get the identity. And that's just x and y on this side. But this side, we actually want to multiply through these two matrices. So we have negative 8 times 11 is negative 88. Minus 2 is negative 90. Then we have negative 33 plus 6 is negative 27. If you want to leave it this way, you can. So this really just means x and y. So our final answer here would be x and y is equal to, oops, excuse me. And notice when you multiply this out, you could multiply that. This would get you a positive 1/2. It's going to get you a weird fraction. Which is why I'm not going to make you multiply it. If you can get it to here, I'm okay with that. Because a lot of times you will get some of those weird fractions. Now we're going to go ahead and move on to part B. For part B, we want to first start by writing our matrix. So we're going to have 6, negative 9, 8, negative 12. Then we have our variables, so we have x and y is equal to, and then we'll have negative 18 and 24. So once we have this, we need to find the inverse of this first matrix. So we're going to pull off to the side here, we do 1 over the determinant, so we have 6 times negative 12 is negative 72, minus negative 9 times 8, which is negative 72. And then we switch them, so we have negative 12, then a positive 9, negative 8, and a positive 6. Here, when these change to positive, this changes to 1 over 0, which we learned last time there is no inverse. If there's no inverse, there's no solution. So whenever we have systems of equations that cannot be solved, there's no solution to them, we end up with no solution because there was no inverse to be found. And you will have that occasionally from time to time. So let's go ahead and look at 2 more here, setting up some of these matrix equations and finding inverses to solve. So first, let's set up the matrix equation. So we'll have negative 2, 3, 4, negative 8 times x and y is equal to negative 7 and 16. Again, we want to start by finding the inverse of this. So to find the inverse, we do 1 over its determinant. So we have 16 minus 12 times, we switch the negative 8 and the negative 2 and make these ones negative. So we end up with 1 over 4 times negative 8, negative 3, negative 4, and negative 2. Now I'm going to multiply both sides by this. Since there's an inverse, there's a solution. So we're going to have 1/4 negative 8, negative 3, negative 4, negative 2 times our regular negative 2, 3, 4, negative 8 times the x and the y is equal to the inverse again. So now we're multiplying the inverse first on the other side. It has to go first so that the dimensions match up. So then we have negative 8, negative 3, negative 4, and negative 2 times the answers we had, which are negative 7 and 16. Again, this whole thing here, all of these should be the identity matrix, as long as we've done it correctly. I'm not going to make you multiply through and find out if it's the identity matrix. We can make the assumption this should give us the identity matrix. So on this side, we're just left with x and y is equal to 1/4 times negative 8 times negative 7 is a positive 56. Negative 48, positive 56 minus 48 is 8. Then we have positive 28 minus 32, 28 minus 32 is a negative 4. Now because these are both divisible by 4 nicely, I'm going to go ahead and multiply through on that, and we get 1/4 times 8 is 2, and 1/4 times negative 4 is a negative 1. What this means, now that I could actually get 2 solutions here, x is 2, y is negative 1. So x is equal to 2, y is equal to negative 1. Because remember, this goes back to what we learned in the first section, with the top is equal to the top, the bottom is equal to the bottom. And that's our solution. So again, it may not be the most convenient way to solve systems of equations, but it is another option that we have. So let's clear ourselves some space. And then we'll take a look at the last example in this section. So again, let's start by writing the equation. 2, negative 4, 3, negative 6 times x and y is equal to negative 24 minus 12. Find the inverse of this. So we have 1 over negative 12 minus negative 12. I think most of you can probably see what's going to happen here. When I change these to addition, that becomes 1 over 0. We don't even care what this is anymore, because there is no inverse, which means there is no solution. Reminder again, not all of your homework problems are going to be no solution, so you should not put no solution for all of them just so you don't have to do them. You still have to work them out. And at the least, I should see you working out the inverse so that you can prove to me that there was no solution if you're saying there's no solution. So there's our homework, page 221, 8 through 22 even. We've officially closed out chapter 4, and we'll be having a test on the entire chapter here in the next couple of days.